Dr. David's double featurette presentation. Today we'll be focusing on empirical formulas. An empirical formula is defined as the simplest positive integer ratio of atoms present in a compound. For more information, we'll head over to Ryan.
Alright, for our first example for the empirical formula, the question is, determine the empirical formula of a compound made when 8.65 grams of iron combines with 3.72 grams of oxygen. So we're going to start this off with iron. Go ahead and draw a chart, like so, and you're going to be using this to be converting from grams to moles. And so you're going to, on the top left section of your chart, you're going to write in the quantity of grams, in this case we're doing iron first, of the whatever element it is you're doing, and you're going to write that in up here. And then down here beneath it, what we're going to do is we're going to get the atomic mass of that that element, which in this case is iron, and our atomic mass is 55.85. Put that in grams as well. And on top we're just going to put 1 mole. And your grams are going to cancel out. And what you're going to do is you'll divide this first number, it should be a decimal point right there. You'll divide this first number by the second one. And in this case, that gives us 0.155 moles of iron. And then beneath it, we're going to start working on oxygen now. So start it off the same way. You draw your same chart, just like in iron. And our quantity for oxygen is 3.72 grams. So I'll write that in the top left-hand corner again. Of oxygen, I forgot my decimal point again. And then, as you should know, you can look at your periodic table. Oxygen's atomic mass is 16.00 grams. And just like last time, you're going to put 1 mole on top. And if you divide 3.72 by your 16, it's going to equal 0.2325 moles of oxygen. Moles of oxygen. Now what you'll do now that you've got both of your quantities in moles, what you're going to do is you'll divide both of these numbers by the smaller of the two number, which in this case is 0.155 because it is smaller than 0.2325. So you're going to divide both of them by your 0.155. And for the iron, that's obviously just going to be 1 because it's the same quantity. And for oxygen, it's actually just going to be 1.5 when you plug that into your calculator. So, but we're not done yet because you can't put a decimal or fraction into your final formula. So what you'll do is you'll find the smallest quantity that you can multiply both of these numbers by so that they're both whole numbers. So you're going to just, in this case it's 2. So you're going to multiply them both by 2. 1 times 2 is just 2. And 1.5 times 2 is just 3. And that makes our final empirical formula, iron, or Fe, Fe2O3. And solving the empirical formula is as simple as that. Now for our next practice problem, I'm going to hand it over to Nick to solve that one for you. Thank you.
For our next problem, we're going to need to determine the empirical formula of a compound that is 29.0% sodium, 40.5% sulfur, and 30.4% oxygen by weight. Alright, so first off, we can draw our t-table. This will help us organize our data, and it'll help us convert our units. So since, we can pick any one of these, why not? Let's pick sodium. So 29.0 grams of sodium. Alright, so now we're going to want to divide it by the molecular mass. And the molecular mass of sodium is 23.0 grams. And then we can put 1 mole. So now that we have 1 mole of sodium, we can find out what that equals. And that equals 1.261 moles of sodium. Alright, so now that we have that one, we can go on to the next one. So we can do another T-chart. And let's do sulfur. So we have 40.5 grams of sulfur. Alright, now the molecular mass of sulfur is 32.1 grams. So now that we can put moles, right, 1 mole right here, sulfur, and that's going to give us 1.261 moles of sulfur, and that's the same as that, and we'll come back to that later. So now for the last one, we're going to do oxygen. So oxygen is 30.4 grams of oxygen, and then the molecular mass of oxygen is 16.0. So we can put that right here. And then 1 mole right here. And so that equals 1.9 moles of oxygen. So now that we have that, we're going to need to divide it by the lowest number that we got here, which in this case is 1.261 moles. So we can divide everything by that number. So that's going to give us 1 on these ones, and that's going to give us 1.5 here. So once we have that, well, we can't have 1.5 in our final answer, so we're going to need to multiply all of these by 2 so that we can get whole numbers. And that's going to give us 2, 2, and 3. So now we have all the information we need, and we can put our final answer as S2 Na 2 oxygen 3. And there you have it. Now we're going to go to David for the outro.
If you have any more questions, be sure to ask Mrs. B in the B wing. But that concludes our empirical formula double featurette presentation. Until the next double featurette presentation. Bye-bye.